group. This can be conversational. I'm encouraging you guys just to unmute and chime in with questions or clarifications. If I'm really on a roll and you feel like you want to type something in the chat, then feel free to do that. And this meeting is being recorded, so please acknowledge that. All right. And to set the stage a little bit, maybe raise your hand if you were able to join Abby's terrestrial resilience presentation last Friday. I think at least a couple of folks, and it's okay if not. Rolling through. There's some really cool elements to this coastal resilience work that are mirrored with the terrestrial resilience tool that that Abby talked about last week. But I'm going to start a little bit larger scale and conceptual. I've worked in the realm of land protection and coastal resilience for 15 years now in South Carolina, and have really wrestled with probably a lot of the same challenges and questions and struggles that you guys have. I also want to add a disclaimer that I am not a GIS guru by training. So I think I am pretty savvy with that realm at this point in my life, probably as many of you are, because we use this as a tool daily. But if you want to get like really in the weeds with some of the analytics behind what we'll discuss today, I will have to defer you to some of my colleagues on that. So the goals for today, again, this is a longer conversation. I want it to feel conversational. I want you to interrupt. I want you to chime in with some of the questions and challenges that you're facing. But let's talk about what is resilience. Let's talk about how land trusts have to kind of scale their thinking about resilience from landscape scale prioritization down to parcel level investments that we may already have on our plate, as Oliver just referred to. We'll visit the TNC Coastal Resilience tool as one of the examples, but for those of you who've played with tools and coastal resilience, what you will likely say is that one of your greatest challenges is that there are so many tools out there to use and try to decipher and understand and apply. So, but we'll go a little bit deeper into TNC's tool, and I've got a case study that I had the opportunity to work on with some folks up in Maine to show you guys how they chose to incorporate TNC's coastal resilience data into many other data sets that were more localized, but that they had access to. What do you mean when we talk about resilience? In general, in coastal landscapes, it means securing the ability of natural or human communities to bounce back after a disturbance, such as hurricanes, coastal storms, and flooding. Resilience relative to climate change is really more about that long-term ability of habitats or human communities to persist in face of that sustained challenge. And so one of the things I might go ahead and note here is that resilience as a term can be ambiguous. It's one that's not always public friendly when we communicate. Folks don't know exactly what we mean when we talk about resilience. It's something that's come back in communication studies that we've done. And so I do think it's helpful to try to be a little bit more explicit when we use the term, and also to define how we're using it if we choose to. We know that coastal areas are strongholds. They're where most of our population lives. but they're also a place that supports critical biodiversity. And the composition of these coastal areas is such that, here, I'm gonna have to move y'all's faces so I can see. That we have natural areas, we have hardened shorelines, we have human communities, and we have really different topography and geology depending on which coastal area you live in. That greatly changes the way we might address securing areas for conservation. We also know that thinking about resilience is just one of the things that land trusts consider when we are protecting properties and prioritizing spaces. So I just want to acknowledge that human resilience and flooding and water quality are themes that I think a lot of us are thinking about in our land protection, but they're just one of many co-benefits that we usually try to address. And so in planning and prioritizing conservation, it's often helpful to go ahead and acknowledge that, and to, in a planning perspective, to go ahead and recognize that we might have several different types of maps that help us understand and prioritize these different co-benefits and to see where they intersect. So some of the other things that our organization thinks about is habitat protection, sprawl management, equitable access to public lands. And all of these are elements that can also be complementary with coastal resilience. But what I've recognized in the last 15 years is that climate is the lens through which we now view all of our work. There's really nothing that we do now where we don't take this into consideration. So how do land trusts engage with climate resilience? And I want to start with what I think we should do as a starting point, is really to familiarize ourselves with the science and the data that's available to us. Often that data is complex. It may mean that we need some assistance in deciphering it and understanding what's available and understanding what's more localized and more relevant and probably the better data to use. I've had the opportunity to train through a program called the Open Standards for Conservation. And so I sort of often think about that conservation by design planning wheel that we all hope we're applying to just to protect the places that are most important. Gosh, and I can hardly read this, so I doubt you can. But first, assembling the data, understanding where we are in the context of that place, setting the priorities, analyzing, and then always completing that kind of adaptive cycle of revisiting information as we do our conservation planning work. And as I mentioned, there are so many different sources of climate data and tools. There are major portals that are available where we can access some of this conservation science that's available to us. We have the Conservation Gateway with the Nature Conservancy. We have the new Center for Resilient Conservation Science, also hosted by TNC. If you were on with Abby last week, you heard a little bit about the difference between these two sites. The Conservation Gateway may have more in-depth information, including the actual physical reports that some of the tools are built on. For coastal areas, we have NOAA's Digital Coast. We have sites like the South Atlantic Landscape Conservation Collaborative. We have the U.S. Climate Resilience Toolkit. So these are just the clearinghouses. And once you get to the clearinghouse, you often have just a myriad of tools and data sets that you can look at. And it is kind of helpful to look at those tools. This is a chart that I found online that I've referenced before, and it breaks down some of these data sets into really what their purpose is this data that we're just going to download. It's not analyzing, it's not a tool, but data that's relevant to climate science. Are they tools that help explain processes? Are they analyzing data? Do they provide visualizations of future conditions such as sea level rise and temperature change? And so all of these are relevant, but obviously have slightly different purposes when trying to understand the science that's available to us. And so we have the first step of collecting the science, understanding what's available to us in our geography, and then a goal often of pursuing the most strategic land protection opportunities that are available, and those that contribute to both adaptation and mitigation of climate impacts. So what are some of the things that we might try to accomplish that are more at the landscape scale? Often we want to use that best available science to define some of our organizational priorities and our future investments in land conservation. We know that climate science is being used by organizations and agencies to define focus areas. Where are we going to work? How are we going to work in those areas? It's being used to assess potential conservation actions and strategies. So really helping us target the type of management that we might choose if we own land, or encourage our landowners if we are easement holders. And more, we see that this scale is being used by our funders, one, to prioritize projects, but also putting it back on land trust as grantees to be able to communicate at the landscape scale, what is sort of the importance, what are the future climate impacts to this area. And so once our funding is dependent on understanding climate science and future condition of sites that we're pursuing, I think it's really relevant to all of us to get educated on it. So what are some of the strategies that we see land trust pursuing? One of the things that we'll talk about in detail today is preserving future migration space. So areas where coastal habitats are shifting and changing, and making sure that there's room for those habitats to move as sea level rise ensues. We are seeing land trust really engaging with their local communities more. And so when we talk about TNC's Coastal Resilience tool today, it's important to remember that that tool was built on the premise that it is prioritizing areas that help to conserve biological diversity into the future. Really has some foundational decisions in the way the model was built that are based on a biodiversity lens. And that's also true for the terrestrial resilience tool. When we are thinking really strictly about how to protect our human communities in the face of climate change, how to use natural infrastructure to protect human communities, there are other tools we might use, or we might look at TNC's resilience tool in a slightly different way to help inform our work with human communities. We see land trusts working to conserve sites that are regionally significant for both biological diversity and resilience. And we see land trust stepping into the realm of restoration. And that was the fact with the group that I worked with in Maine. They had really gone in with both feet and started to get savvy about how to secure funding and set priorities and move forward with hydrologic restoration in some of their coastal sites, which is exciting to see Land Trust moving into that realm. We've got partners in South Carolina like Ducks Unlimited that have worked in that realm of restoration and hydrologic connectivity for a long time. And it certainly is relevant to our climate work as well. And then we've got our investments that are already on the ground. We've got an impetus behind what's the best we can do for those places that we already own or that we hold easements on, right? And I think in some ways, these are some of our largest challenges. A lot of the folks that I've worked with over the years are refuge managers with static boundaries, national wildlife refuges that are, squarely in the path of sea level rise and were developed to protect freshwater forested wetlands, and now see, salinity intrusion coming into those wetlands. How do they do the best work that they can do with the sites that are already in their care in these coastal areas? So what are some of the things that we might try to accomplish at that parcel level? Obviously, restoration and management are important components of our work at the parcel level, and being able to make informed decisions that help to facilitate migration of habitats, movement of habitats within the lands that we own and manage. But another thing that I've presented on a good bit, and I just want to touch on it because it's a really kind of fun thought process to go down, and there are folks that have done some great thought work on this. But one of the important things for Land Trust to do is to think about resilience in our easement templates. So we know that there's the opportunity to establish enforceable and clear goals and standards in conservation easements that help to ensure that terrestrial and aquatic wildlife are able to move and be sustained on the properties that we have under easement, that allow for again, landforms that provide microclimates not to be damaged, for sensitive or underprotected geology or habitat types to have special protections, and to protect migration space. So those areas, and this is particularly relevant in coastal areas, areas that might be influenced or tidally influenced coastal habitats that can be protected, that can be buffer areas that might not allow for future buildings or sites. So this concept of resilient easements, there's a guy, Olmsted, who's written a good bit about this, and we could probably send around some of his papers. But one of the challenges that I think he has put out to the Land Trust community is for us really to make sure that we're thinking carefully about our language for the conservation values that we cite. So we know that easements can contain a severability clause that states that when one purpose ceases to exist, that another purpose can take precedent over that. And so if we have hung our hats in our conservation easements and are only citing habitats as the conservation values that the easement was designed to protect, and those habitats are not going to be sustained on that property because they're going to shift off of it, they're not necessarily likely to be there in the future. It's important for us to think about what are going to be the enduring qualities in the face of sea level rise, in the face of climate change, that are likely to persist on these sites, and that we can be sure and incorporate when we design our easements. Does anyone have any questions about that or any experience thinking that through with your easements? I had a couple of the land trust groups that I've worked with actually change up their conservation easement templates to incorporate some of this kind of thinking into it. Another thing we can do just as a template approach is to really broaden the baseline documentation report for conservation easements, include detailed descriptions and maps of the property's climate resilient characteristics. What are the obstacles on the site to that resilience? We might be sure to denote the soils and geophysical settings, the tidal complexes that we have on the site, look at the corridors and connectivity, floodplain areas, including 100-year floodplain areas, and to think about mapping some of those fragmenting features. And of course, also in the easement, to think about limiting some of those fragmenting features on site. And we have the opportunity as well to incorporate climate resilient science into our management plans. So as I said before, for those properties that we own, to take the time to understand really what is the work that the land trust can be doing to facilitate change on these sites, to allow for habitats to shift and move, and to, for instance, remove invasive species that are issues. I had one land trust group that used a tool that NOAA had developed, which was really a decision support tool. It's got a terrible acronym called CVATCH, Coastal Vulnerability Assessment Tool. But it's a decision support tool, Excel based, that really helps land trust groups go through and think about how are certain habitat types going to be impacted, what are some of the interventions that are available, and to develop management plans at the site level. And so they started incorporating that into their baseline reports and also into their management plans to make sure they'd gone through that process of really using the best science that they had. And as I mentioned, we've got groups out there that are moving into the realm of restoration and managing coastal habitats. I worked with the Nature Conservancy before I was with OSI in South Carolina, and oyster restoration was a tremendous intervention that we worked on in those coastal landscapes. So helping to develop and deploy some of the natural infrastructure that we know is going to be so important to sustaining our coastal habitats over time, and also protecting human communities over time. I just wanted to mention this because this is one of the more fun sort of on the ground interventions that any of the land trust groups that I've worked with have done. So they developed a strategy on some of the sites that they own to actually remove invasives, to go in and do some forest restoration on these sites. They actually did it on both easement sites and on sites that they owned, but they put a call out to their membership. And so it was a dual effort of adaptive management on their sites and also a way to communicate and educate their membership base to get out and engage in these work days that help to advance their climate strategies. This is in a Piedmont area of South Carolina, so not exactly relevant to our coastal habitats, but you can imagine how it could be. I'm going to pause there just to see if there are any questions about sort of the broad conceptual overview of how land trust groups are engaging in coastal resilience. Or I would really like if someone would throw out other examples that you have from your land trust. Might call on you.
Well, this is Bill. I can just say one thing. I really appreciate the thinking about the adaptive look at easements and how they can change. And what we really need to do is recognize the potential changes through climate change and resilience that need to be accommodated in the easement. And when I think about our forest easements, that really comes to mind as well.
Thanks, Bill. Yeah, you know, one thought exercise that that I've seen land trusts do is actually to do a backwards look at all of the easements that they administer, and to look at sort of the resilience that's built in to those easements. It's really interesting. You know, we make a lot of assumptions when we look at a map that's colored green and we see easements in place in coastal habitats, but many of our older easements are going to allow for buildings in the marsh migration space and other real obstacles. I mean, that the map being colored green does not mean that the pathway is necessarily clear. So there's a lot of kind of forward facing work we can do. I think there's also some backwards facing work in lands that we already manage. Anyone else before I dive in? All right. I've taught a lot of college classes in the past, so I'm not afraid to pick on you guys. All on y'all.
Good to know.
All right, well, let's dive into TNC's coastal resilience tool as an example of many, many tools that are out there to help us prioritize coastal habitats for protection. And I did want to acknowledge that both TNC and Mark Anderson in these next slides that will show, most of them were provided to us by Mark with his permission to use for this webinar. And he's just been such a great partner over the years. Abby cited this as well with the terrestrial resilience work. One of the spaces that OSI has worked in, and so part of what we're doing today is really to be a conduit between the groups on the ground and some of the emerging science that's great and that we hope to see deployed on the ground. And so that's a role that OSI has served over the years with these resilience tools. And so I hope, you know, if you have follow-up questions, we're happy to continue to play that role of trying to make this somewhat complicated science available to you and understandable to you. This is sort of a long quote that I pulled out of TNC's report on this resilience tool, but you can sort of read it while I also summarize what we're saying here. So what is TNC's approach to coastal resilience? As I said at the beginning, there are a lot of sort of principles in the approach to this tool that are very much parallel to the way they approach their terrestrial resilience tool. So TNC's approach really focuses on resilient characteristics of underlying geophysical settings. It is a focus on what Mark calls the stage and not the actors. It helps us understand where do we have the geophysical diversity that's going to sustain and support the biological diversity into the future, even as we see all these forces of climate and particularly of sea level rise in this case. So it assumes that the biological systems will change in concert with that changing climate, but that certain sites have enduring physical characteristics that will give them a larger capacity to supporting diversity into the future. So supporting diversity, ecological function, and productivity into the future. So some of the papers on this concept that have been written are under Conserving Nature stage. And again, the concept is conserve the stage, not the actors. Mark has a really fascinating analogy about baseball fields and how the players change, but the field's always there. But I think if you haven't gone deep into the science, it'll make sense as we talk through it. And all of this is available, easily accessible through TNC's Conservation Gateway site. You have access to the full reports, and there are, for this coastal resilience science, separate reports for the Northeast region and the Southeast region. The tool was sort of built out over time with first the Northeast, then the Southeast, and then the Gulf states coming online. So really each region gets an individualized report that you can refer to. There's the web-based mapping tool, which is very user-friendly and has a lot of ways that you can sort of zoom in. Every time you click on a zoomed in area, there is a window that pops up that gives some nice detailed information about interpreting what you're looking at. They're great story maps that go through how this tool can be used, and then also places where you can directly download the data. You also have the ability to upload parcel shape files into the tool to do analytics with the web-based mapping tool. One thing I wanted to make sure I didn't forget to say was that in the development of the tool, for instance, in the Southeast, Mark and collaborators identified a little over 1,200 sites that were analyzed. These are the sites that in the coastal realm that they scored. There were certain criteria that they used that really narrowed down the number of sites that were scored. So for the Southeast, one of the things they recognized was that unconsolidated tidal flats were just not going to work as a standalone system that they could score. That habitat type dominated the sites that emerged as potential sites to score. So when we cut that, about 90% of our sites went away. We also limited sites to 2 acres. So only sites that were at least 2 acres in size were scored. And then these sites were further divided into coastal shoreline regions. So when we look at the scores on this tool, what we're seeing are actually scores that are relative to individualized coastal shoreline regions. So in the Southeast, there are 4 that were defined. Florida's island archipelago, we have a lagoonal site, and then 2 different types of coastal riverine sites. So each of those are really discrete and should be viewed as unique. And to recall that scores are relative only to other sites within that type. The other thing that I think is important to remember off the bat, and this was something that I had to wrap my head around, is that we talk about marsh migration space. Usually we just use the term marsh as a catch-all, but actually this tool and many others are about a tidal complex that includes beach and dune sites. It includes tidal flats. It includes brackish marsh, salt marsh, and in the coastal areas, our marsh migration space actually also includes tidal freshwater wetlands. So all of those complexes within the tidal zone are part of the analysis, even though we use this catch-all term of marsh most frequently. The figure on the right, if you spend a little bit of time with it, is comparing NOAA's CCAP land cover data that looks at tidal complexes with some of the first base analyses of TNC's tool that shows their tidal complex. And then what you're seeing is that marsh migration space that's defined by TNC's tool at various sea level intervals. So the tool was developed with 4 different sea level rise intervals from 1.5 feet to 6.5. But the base sea level rise that was used for the final projections is the highest, the 6.5 feet of sea level rise. So the tidal, these marsh migration complexes and the sites that show the greatest resilience are those that actually are anticipated to be able to persist and thrive even at 6.5 feet of sea level rise. And I've got lots of projections of sort of migration space versus the extant tidal complexes. And so whenever you're looking at the mapping tool, it is good to remind yourself, okay, where are we saying there's currently healthy, intact tidal, extant tidal marsh systems or tidal systems, and where are we saying that we anticipate those being in the future? So again, that marsh migration space that we see in orange is that area of low-lying suitable habitat that is likely to accommodate tidal habitats into the future. Developed areas were excluded from the marsh migration space. Roads were excluded from that area. And obviously we have geologic features that are not gonna, even though they're natural cover, they are not appropriate migration space. So elevation, topography, and existing land use type all factor into what qualified as migration space. So we're going to dig in a little bit into the physical factors that were used in this tool and the condition factors. If you are familiar with TNC's terrestrial resilience tool, this is comparable to the diversity score versus the connectedness score. So think, physical attributes of a space that are unlikely to change for these physical factors, and then maybe some malleable condition factors that we actually have the opportunity to influence over time and might shine light on some of the strategies that our land trusts develop to address improving conditions within the spaces where we work. So we'll go into each one of these in a little bit more detail. So that first question on what are we looking for? What does the site actually have the physical space for the habitat to migrate into? So one of the things that TNC wanted to ensure that the tool corrected for was that it wasn't identifying really high quality, great marsh space that had zero migration space, that didn't have any pathway for that tidal complex to persist into the future. And so for a site to have a high score, it needs to demonstrate that there is a pathway for migration space, and migration space was scored based on the size of that space, the accessibility of it, as in the fact that it's low lying and that it can accommodate that movement, that it doesn't have developed or hardened edges that are going to hinder movement. The amount of shared marsh edge, so literally linear feet of shared edge, and then the diversity of the tidal complexes within it. So here are the, and what is the condition score based on? So when you think condition, think what do we know that we need in the landscape to sustain healthy marshes into the future? What are the factors that are going to degrade or even disallow marshes from persisting into the future? And so if we've got the physical space, do we also have the conditions that are appropriate for sustaining marshes into the future? So the developed edge was one characteristic of hindering that. The sediment balance, do we actually have enough natural flow of coming from our rivers and streams that feed our marshes, where the sediment can actually keep up with sea level rise and allow our marshes to persist into the future? So we know that we need accretion in our marshes. We need our marshes to be building up at a certain rate. That building is supported by the sediment supply. And if it's not there, our marshes are unlikely to be able to keep up with the rate of sea level rise and persist into the future. Water quality is another feature that was considered, particularly nutrients in the water that eventually degrade marshes, even though they initially give them a little growth boost. And then also freshwater flow. So the ability to actually see those pulses of freshwater coming in that help sustain diversity. We're going to talk about each one of these again and make sure that this is clear. But again, just chime in, raise your hand, or interrupt me if you want to revisit any of these. So here's an example of an existing tidal complex in green, and it's marsh migration space that's available as future marsh or tidal complex in orange, based on the different sea level rise scenarios that you can see in that gradient of orange. And so this is a marsh migration space that shows that the future marsh potential is actually larger than the current existing marsh. This is something that we saw play out a few times in this, particularly in the southeastern United States. So large expansive areas that don't currently have marsh that might have marsh in the future. This marsh migration space happens to be 13,000 acres. We saw in this that the tidal zones, how many tidal zones are within the space, which is a proxy for different habitat types within that space. That score was above average for the space. How much shared edge of existing marsh with the future marsh space? And again, in this instance, we saw that was above average. And how large is the current complex and source for biotic material? So that's how big is our existing marsh space? And again, we had an above average score. So this is one of those sites where we really saw exceptional intact existing marsh and the potential for marsh migration. I am curious if anyone has a comment on what do you think this marsh migration space is comprised of today? Can you tell by looking at that space?
Farmland?
It could be, actually. Good answer. Do you see sort of the sinuous nature? It's following a river channel, right? It's mostly in the floodplain of that river channel, likely. And so what we have here is the marsh migration space. There's likely some space that is upland space that is prone to development in this area that is marsh migration space, but probably a lot of this marsh migration space is actually currently freshwater wetlands. So that's sort of an interesting phenomenon that that we saw quite a bit with this tool in the Southeast, that there's not a lot of development threat. We're not going to remove the threat of development in freshwater riverine wetlands that go up these systems. But what this is saying is that we're likely to see that tidal extent and salinity move into areas that currently harbor probably freshwater forested wetlands. And so we would see a transition of swamp forest to grasses and salt marsh in the future. I might not drill you guys too much on this, but I wanted the details of some of the condition score information to be available to you. This gives you a little bit more information on where this information was derived from. So total suspended matter, the concentration of sediment in our riverine watersheds is actually derived from satellite data that can kind of score and quantify that for us. Amazingly, only coastal Georgia shows up as really above average for sediment supply. Might be the only state that showed up showing a balance of sediment in the river systems that actually keeps pace with sea level rise. And then we see areas that are really struggling with their sediment balance, right? And so that's certainly the Gulf states, an intervention point for folks to think about. A little more on nitrogen and nutrients. You know, nitrogen is responsible for eutrophication in our waterways, and heavy doses of nitrogen coming down riverine systems give, and you can see here like a little initial boost to marsh grasses, but we actually see loss of root systems in this case. And so we might have a nice little flush of our marsh grasses, but over time the root system can't sustain, and we see degradation of marsh areas and weakened root systems and loss of that stability when nutrients are too high. So again, nutrients are an intervention point that we can think about when we look at our condition scores, if we have physical features that are intact. And then freshwater inflow is necessary for healthy and productive coastal estuaries. Again, that kind of flow, as well as the sediment supply, is often hindered by upstream dams. So areas with less altered flows got higher scores for freshwater flow. So again, the tool meshes for a final score the physical attributes of the site with the condition attributes of these sites. So those sites that met the migration space threshold, that they actually had a space to move into, are the ones that were scored. The physical weight is 75% of the score, and that condition weight's 25%. This, again, just kind of lists physical features of the tidal complex that were part of the score and those condition features. And what we have in the box to the right is clipped directly from the report and gives you the actual weight of each of these features and how they fit into the final model. And it is interesting, again, I don't think I'm about to visit the buffer area around our tidal complexes. Just keep it in your head, buffer areas contribute to about 80% of the final score. So one of the sort of condition features that were also considered is a much larger buffer area around the existing marsh and the migration space. So we know that that whether or not these areas around our existing and future marsh are in natural habitat or whether they are developed has a profound impact on the condition of those sites. So buffer areas were also part of the scoring, looking at how much developed space existed in those buffer areas, the size of the buffer, the variety of landforms within the buffer, and all that became part of the score. So how do we see Land Trust potentially using this tool? Obviously, we see Land Trust thinking about land acquisition within high scoring migration spaces. That's an obvious use of the tool. We want to make sure and secure the pathway for future migration. We see them thinking about ways to abate threats of future development within migration space or within buffer areas. And so I have encouraged Land Trust I've worked with in the group have gotten discrete shape files that help define, what was the buffer area that was being considered for a particular complex. And that's something that you might incorporate into your conservation planning to think about keeping those areas in a natural state. We have groups investing in natural solutions in sites that have large resilient sites and large human populations. I do think in just a minute, when we look at 12 Rivers, you'll see how they brought some human element into their strategies and plans. And we have groups wading into the realm of restoration, actually trying to intervene in places where we have barriers in our coastal marsh complexes, where we can increase hydrologic connectivity or increase rates of accretion by adding things like oyster beds. If we don't have enough sediment supply coming downstream, we can augment sediment supply by creating natural infrastructure like oyster beds that help to capture sediment for marsh habitats. And then we have folks that put a biodiversity lens on things. So they might pair biodiversity information with this tool and look at what kind of biodiversity do we see in some of these migration spaces and prioritize based on that. I'm going to go relatively quickly through these slides, and this is a bit of a case study, but we just went super deep on this resilience tool. So I'm going to pause first to see if anyone has questions or anything they want to revisit. I can only see Abby, Oliver, and Hallie's faces. So I've got y'all down in the corner of my screen. Anyone worked with this particular tool or want to throw out another one that they've found be helpful?
I have a question, Mariah. I was just wondering sort of the geographic extent of this tool. You showed sort of the regions in the Southeast. Is there good coverage in other coastal areas?
Absolutely, yes. We have coverage throughout the US with this coastal tool now. It was first developed for the Northeast, so that was available first, and the Gulf states just came online maybe a couple of years ago. But Abby, I think I'm correct that this is built out all the way to the West Coast at this point.
I don't know if it's done on the California coast, actually.
Okay.
Yeah, that's a good question, but I know it covers the East. And yeah. I would be I'm interested for the folks on the call, like where if this work addresses the kinds of questions you've had, like that you're trying to answer.
I'll jump in quickly. I'm in Rochester, New York, up on Lake Ontario. So definitely a different coast system. But as we were working with Joel on a technical assistance grant, thinking about strategic conservation planning, saw this topic, and this tool is certainly very interesting to sort of think about when it comes to land adjacent to Lake Ontario and some of the Finger Lakes throughout our region.
Yeah, and this is Oliver at Natural Lands in the eastern Pennsylvania, southern New Jersey. And as I mentioned, when I got on the call, we have pretty substantial holdings, at least based on the region we're in, about 8,000 acres or so of coastal land on the Delaware Bay Shore, tidal marsh, some beachfront as well. That's important migratory habitat. And we've just started to tap into this tool for the coastal areas. We've been looking for it more, in terms of the upland land that we have in Pennsylvania, but we're struggling with the realities of the sea level rise, saltwater intrusion that's already killing off old growth forest and already impacting our preserves, and also trying to figure out, okay, what's there worth continuing to steward and support, and what should our land protection goals be in that landscape moving forward, given the trajectory of sea level rise. So this is very helpful. I'm particularly curious to see in this case study, and also hear other examples, if you have them, of how people have managed environmental justice issues in this context. I mean, where we're working are the two poorest counties in New Jersey. And so, there are tough issues here.
Really tough. Thanks, Oliver. Okay, well, I'm going to run through this main case study, and then I'm hoping that leaves us a little more time for conversation around some of these challenges that we're all thinking about. So I had the chance to work as a circuit rider with this coastal resilience data with a group in Maine that is a collaboration of 5 local and 1 state land trusts. They call themselves the 12 Rivers Conservation Initiative. They had already gone through sort of a focal area defining exercise and a prioritization with using the Nature Conservancy's terrestrial resilience tool. And they were really interested in incorporating coastal resilience element into this work. So you get the sense it's about an 800,000 acre landscape geography with many, many partners involved. So as I said at the beginning, one of the biggest exercises for this partnership was sorting through the data that was available to them. And it was hefty. They had lots of what we would call current condition data, really detailed inventory type data of extant species of concern, critical areas for wildlife habitat defined. And they were really interested in making sure they had a sense of that current condition element. That's something that we know is important to understanding resilience. Abby gave a really great sort of case for trusting our physical features of sites as a proxy for biodiversity on the landscape. And I think, a lot of this is built on that premise. But when we have great biological condition data, it doesn't hurt to use it sometimes. And these guys were interested in incorporating that. So you see just a heap of current condition data. They had sea level rise scenarios, so future condition data that they wanted to incorporate. They had that data that was localized, that had been produced by Maine's Geological Survey, but also they had the NOAA Sea Level Rise Viewer. And I didn't mention that NOAA's sea level rise viewer was the data that was adapted and used for TNC's coastal resilience tool. They had some, again, localized analyses that mapped tidal marsh migration areas in Maine using 4 sea level rise scenarios. They had an exercise that Maine's Natural Areas Program had gone through to map out coastal undeveloped habitat blocks. And then they had this resilience modeling. So they already had ranking of those coastal undeveloped blocks that Maine's Natural Areas Program had developed. And then they had TNC's coastal resilience data that they wanted to make sure they incorporated into that ranking, because there were some different and unique attributes, including an assessment of unconsolidated base and tidal flats that was part of tidal complexes in TNC's resilience tool that was missing in their other existing ranked undeveloped blocks tool. So they also had some really cool work that the main chapter of the Nature Conservancy had been doing that included human elements. So they had a coastal risk explorer that looked just at what Oliver was saying, really gave them a sense of areas that were both at highest risk and maybe had the highest social vulnerability that were likely to be exposed and vulnerable. And they also had a second similar tool that the National Fish and Wildlife Federation had developed, the Community Exposure Index. So they also wanted to be able to incorporate that human element into some of their final products. And then they had ranking habitat and human community resilience through that National Fish and Wildlife Foundation assessment that had been done in their geography. So they really had 2 goals in this project. One, they wanted to evaluate and incorporate currently available coastal climate change resilience mapping into their local and regional strategic plan. 2, they wanted to be able to identify and prioritize sites for resilience projects and restoration projects, like tidal restoration and living shorelines. So one of the things they decided to do was to rework that Maine Natural Areas Program ranked coastal blocks and incorporate in an additive way TNC's coastal resilience tool as well. So they clipped the coastal resilience tool to these mapped blocks. They weren't really interested in adding space, but they wanted to understand the relative scores, how these combined scores would maybe shake up with the prioritization of what they already had that they were working with. And so their final map product that incorporated both of those resilience data sets looked like this. But the work they were really ready to roll up their sleeves and try to address was this tidal restoration element. And so, you know, when you've got a 12-foot tidal range, you really end up with some interesting landscape attributes and challenges when you have barriers to hydrologic flow in your landscape. And you can see right here in this Google Earth and in the photographs, this is a road crossing with a culvert area that was not sufficient to meet the flow of this area. And this is a replaced bridge that allows really, you know, for most of the natural flow to proceed. And what we see here just in a 3-year period is look at that downstream area where we have scouring that happened during high tides as the water came in quickly and wasn't able to, was impeded by the barrier there, and how quickly that marsh restored and recovered with the appropriate replacement in place. And so this was a project that that one of the conservation groups had helped to spearhead. And they were interested in, where are areas that we can do more of this type of work. And so they had an incredible mapping layer that showed all of their tidal crossings, so all of the road sites. And they were able to look at how that intersected with their priority land areas on their map. And, they put a lot of thought into how are we going to actually prioritize which of these tidal crossings might be most important. They had a stream barrier survey, so they actually had a pretty good working knowledge of which of those tidal crossings imposed an impediment to hydrologic flow, and therefore a degrading factor to marsh movement and migration. And they also could combine that with the TNC human community resilience mapping to understand where do we also have road crossings that are being inundated or likely to be inundated that are adjacent to vulnerable communities. And so that gave them the opportunity to really kind of to mesh. All right, we've got this whole array of potential investments for improving hydrologic connectivity, improving condition of our existing tidal complexes. Which of these are going to be most important for sustaining the areas that are most resilient from a biodiversity lens, and which of these might be most important for our socially vulnerable populations within this landscape. And so it was a really cool project for what was available to them to support some of this decision making that they were interested in moving forward. And these were some of the considerations that they were bouncing around. Well, how do we want to prioritize these based on the condition of the marsh, the area of upstream potential marsh, the area available for migration in the future, the human community impacts. They also had shellfish habitat data, adjacent fish passage data. All of these were elements that were of interest. And I do not have any more slides on that, but wanted to throw that out there just as a little lead in for some more conversation and questions from you guys.
Well, one thing, Mariah, that came up was a little bit about the demographics and the equity side of this. And I happen to know that you have a lot of expertise in that area. So I was wondering if maybe you wanted to talk to that.
Yeah, I will say that, we have given the human community side of this a lot of thought. I will say it's still, we're learning as we go. A lot of the work that I'm engaged in where there's a human vulnerability component is in coastal South Carolina, where we have in some cases communities of color that are experiencing repeat flooding. And we're really trying to do some community up planning on how we use natural infrastructure to support and sustain vulnerable communities in some of these coastal areas. I mean, one of the things that I have learned from experience now is that, the concept of buyouts and retreat is not, is often, not on the table. It's not a topic that communities that feel very connected to their place, despite their challenges, are interested in. I'm curious if others have had that same experience. And Abby, maybe you guys can speak to some of the mapping products for social vulnerability that are out there. Hallie?
Well, I will just build a bit on what Mariah shared about the Maine Coastal Risk Explorer utilizes a social vulnerability index that's adapted from a nationally available data set from the U.S. Centers for Disease Control that looks at social vulnerability through a variety of lenses, looking at things like access to transportation and the housing structure, as well as population demographics that really indicate sort of structural inequities that are built into the places where we work. And so that is a tool that is definitely available, as a layer in GIS, but there's also some web-based tools that you can begin to explore. I would say that's one lens to begin to get to know some of the physical and social aspects of vulnerability in a community, but it's not a substitute for the really deep place-based community building work of really understanding both risks and community assets.
Yeah, and Aubrey, I often sort of when I've looked at this tool and when I weigh, what's our purpose in some of the projects, the natural infrastructure for protecting human communities, particularly vulnerable ones, is one that's of great interest to me as well. And it's hard to piece apart science. As I said at the beginning, this resilience tool is really about biological diversity. I think there are elements that we can use to make inferences for human communities, but it's probably a different set of tools that we're going to use to understand when we can use natural infrastructure to really help protect some of our human communities. And what's best is when we see those opportunities that compound, as I think the main example shows you, that there were some cool opportunities for them to try to pair habitat results with human community benefits.
The only thing I was going to add too is just the migration space, like looking at who that impacts is one just very basic fundamental piece that can be important. And that a starting place, depending on your scale, might be the data Hallie talked about, and understanding their different vulnerabilities and just being aware of those sensitivities.
Yeah, that's a great point, Abby. And there are a lot of assumptions built into this tool about existing development being a proxy for predicting where we're going to have future hardened shorelines. But I have had the chance in South Carolina, and our colleague Justin hopped off, but Justin really was the one spearheading a FEMA buyout where he worked for Ducks Unlimited at that time. And it was a really cool example of a local land trust guiding a community through a FEMA post-disaster application process, and being willing to be the one to steward that application through, conduct the buyouts, and with the end strategy of transferring those lands to a national wildlife refuge. You know, a lot of our buyout lands end up as postage stamp mode areas and don't really restore natural functions. And that's a space I think a lot of us land trust groups are, you know, not necessarily quite ready to jump into, and also requires quite a bit of capital because it is a reimbursement program. But when I look at Mark's model, one of the things that occurs to me is, you know, there are communities that are ready for that, that are ready for the retreat strategy, and that's one we can consider and help to facilitate, even if the land trust groups aren't the ones doing it. Having the planning in place and having some sense of willing sellers for areas where we have repeat flooding is, you know, a tremendous step forward in reclaiming migration space.
Yeah, we've certainly seen that in Delaware Bay. There's a community named Seabreeze that was acquired by the state, and that was, you know, where the sea level was rising, and now, you know, that town couldn't occupy that space because now the sea level's higher. But I had another question. You know, that a lot of fascinating new information and a way to think about things. You know, when you think about ghost forests everywhere, are these places where, you know, we're actually seeing migrating marshes, or, you know, this tool can tell you where we're just losing forest and the marshes aren't migrating? And then
No,
I was
that's such a good question, Bill. Yeah.
Yeah,
Do you want me to answer that first? You got a double. You
go
got a
ahead,
double.
and then I have another one. Go ahead.
Before this tool was available, I spent a lot of years working with a particular national wildlife refuge on looking at where there were predicted ghost forests. You know, it was a refuge that had just expansive tidal freshwater wetlands that were already shifting to brackish marsh, Bill. So yes, ghost forests are just transition on the ground. It's future marsh. It's what Mark celebrates in his report, where some people on the ground are like, oh God, we're losing our forests. I do think it's healthy and important for us to reframe embracing that transition and, you know, seeing where we have connected tidal habitats that are going to accommodate future marsh, even if it means we're losing the other habitat type. In the case of this particular wildlife refuge, their iconic focal species was the swallowtail kite, incredible, beautiful raptor that occupies southern swamp forests. So one of their strategies was to protect upstream freshwater tidal wetlands that would be able to accommodate swallowtail kite nesting as many of the existing nesting sites transition to ghost forest and marsh. So yeah, that's marsh migration.
Well, these tools hopefully can help predict where where we may gain marsh and not just lose forest. And then I had another question about the sediment being a limiting factor in, you know, the marsh restoration. You know, I've been doing some reading about the ability of marshes to trap and sequester carbon, and a lot of it has to do with the carbon trapped in the sediments. And I'm just thinking, you know, where you see abundant sediment coming in, would those marshes trap more carbon than in places where, you know, it's limited?
I think so. I think you just showed you know more than me about that exact.
No, I just wondered.
Yeah,
Just a
that's
question.
really interesting. I will, just as a thought on this kind of blue carbon, you know, another one that there's been some serious accounting on our former rice fields in coastal South Carolina that have been managed as duck impoundments, and how those are serving as carbon stocks, and also how to accommodate flow even of opening and closing of impoundment infrastructure that is going to allow for for those to accrete over time. I mean, that in itself is, a system of great its importance in some regions of the Southeast.
Well, thank you. Yeah, and it's not just that the marsh can move, it's like how efficient it is in trapping carbon and functioning in
Yeah.
climate change.
Yeah, and I mean, there are interventions out there to make up for sediment supply. Have you guys seen folks that go out to spray sediment on marsh habitats to help with accretion? And I do think this tool is an interesting one in helping us understand some of those condition challenges and to think about what sorts of interventions might be needed to support some of those future coastal habitats. Well, thank you guys for sticking with us. It's a longer lecture, but I really appreciate y'all being here for the duration. Any final pressing questions before we sign off?
Well, Mariah, let me just say I really appreciated learning about all this tool has to offer, and just revisit one comment that was made very, very quickly, if I may, and that is that some land trusts are maybe a little hesitant to engage with the tool and embed themselves in some of the work that's involved. I think what we're starting to see, especially where I work, which is on the coast, at least between Norfolk and Newark, is that we've got organizations that run the gamut and can enter into both the planning space and the implementation space in a variety of different ways, at a variety of different levels of sophistication. And I think what this tool, just as a one-off observation, is that it kind of gives a pathway in for those organizations who might be further back on the level of engagement. I can kind of see them using this as a gateway drug, so to speak, to get more involved. I'm pretty excited about its prospects in that regard. But that's just me babbling. That's just my hopes. But it certainly would invite further conversation as to how we can do that.
Thanks, Andrew. Well, thanks so much, everyone. And please reach out with other questions or comments or ideas. Certainly would love to hear your thoughts on how this applies to your work. Bye, guys.
Thank
Thank
you.
you so much.
Bye-bye.
Thanks for being here.
Thank you.